Sweater?
Actually?
Yeah. Anybody else need a sweater? Because I got a big blanket. You want it?
I do.
Right. Oh, man.
Thank you.
All right, good. Good afternoon.
It's so weird because I come from the tardy, so it's just boiling up. And it's like,
Yeah. All right. Today we are doing some good stuff here. We are going to talk about implicit equations briefly, and we want to really be able to evaluate functions graphically and algebraically. So kind of a nice, easy day today. But first we're going to start talking about implicit or versus explicit equations. So an explicit equation is an equation solved for a specific variable. S-P-E-C-I-F-I-C, specific variable. They're very easy to identify because they're all going to say something like y equals 2x plus 7. So that's an example of an explicit equation. The y is by itself. Or maybe x equals the cube root of y minus 4. Again, the x is by itself. Or maybe we have something like y equals x squared minus 2x plus 7. So again, when a variable is isolated all by itself, then it's an explicit equation, okay? An implicit equation is an equation that is not solved, an equation that is not solved for a variable. And so in this case, we would have mixtures of x's and y's. Nothing is isolated. So for example, x squared plus y squared equals 16. Is the x alone? Is the y alone? No. Then this is an implicit equation. It's an implied equation. That's what it means, okay? We might see something like y squared plus 9x equals 7. Again, is the y by itself? No. Is the x by itself? No. Now, the difference here is that when we have an implicit equation, we can do some work to make it explicit, okay? And so we want to write each equation explicitly in terms of x. So this is an interesting statement, in terms of x. So we want to, when it says in terms of x, we want to have an equation where we have a couple of terms and they have x's in them, okay? And so what we want to do here is we are going to solve for y. We are going to isolate the y. How do I isolate the y in number one? Subtract the x. So you get negative 4y equals negative x plus 20. And then we need to divide everything by negative 4. I'm going to divide every single thing by negative 4, and I get y equals, negative divided by negative is positive 1/4 x, and then a negative 5. Now, when I look at this equation, we want to now ask ourselves to indicate whether or not this equation is a function. And we can do that a lot of different ways. Do you know the shape of that equation? Y equals 1/4 x minus 5. What does that look like? It's linear. It's linear. It's a line. Y equals mx plus b. And so one thing that you can do when we solve for y is we could graph it and see what it is. So when in doubt, graph it out is my favorite phrase. Is it a function? Yes, it is. It is a line. And so, yes, it's a function because it passes the vertical line test. Let's look at number 2. I need to get y by itself. What are we going to do first? Subtract x squared. So I have y squared equals negative x squared plus 25. And then what do we need to do? Square root both sides. When you take a square root, what do you have to remember? Plus or minus. Very good. Don't forget the plus or minus. We get y equals plus or minus the square root of negative x squared plus 25. Now, here's the question. Y is by itself. It's an explicit equation. Is it a function? Because there's a plus and minus. So here's what happens. Let's say that I plug in, let's say that I plug in a 4, all right? If I plug in a 4, if x equals 4, and I plug in a 4, then we would have 4 squared, which is 16. It's got a negative in front, so it becomes negative 16 plus 25. So if I plug in a 4, right now I'm looking at negative 16 plus 25, 9. Okay, so we have plus or minus the square root of 9. And so then we have plus or minus, 3. All right, so y equals plus or minus 3. If I plug in a 4, how many outputs are there? 2. There's a positive 3 and there's a negative 3. Graphically, if I were to graph this, there are 2 equations here. Positive radical negative x squared minus 25. And then there's the other equation, the negative radical negative x squared minus 25. It does not pass the vertical line test. This is half of a circle. Semicircle. Oh, dude. Should be there. I'm not quite sure why it's not graphing. Maybe it's just really slow. I'm waiting for the calculator to graph. I don't know why it's so slow though. Oops. There it goes. Okay, for some reason it doesn't like the order. Hold on. Let me change that around. 25 minus x squared. Okay, x squared, sorry. For some reason, I don't know why it doesn't like it in that form, but this is the same exact thing. Okay, so this is, it should be a circle, even though it doesn't look like a circle. We get the positive, which is the top half of the circle, so the top semicircle. The negative is the upside down one, the negative y values. We got positive y values and negative y values. It is not a function because there are plus or minus. There's 2 outputs. There's going to be 2 y values that are happening there. And crazy. All right, let's look at number 3. We got to get y by itself. What should we do first? Add the x. Y plus 1 quantity squared equals x plus 3, or 3 plus x. And then what should we do? Square root. What do you need to remember when you take a square root? Plus or minus. Very good. So we have y plus 1 is equal to plus or minus the square root of x plus 3. And then we need to subtract the 1 to the other side. So we get y equals negative 1 plus or minus the square root of x plus 3. Again, what is that plus or minus doing? Creating 2 outputs, okay? So if I were to plug in a number for x, we'd have negative 1 plus that thing, and we have negative 1 minus that thing, which would give me 2 different outputs. Is this going to give me a function? No, not a function. And again, we could graph each of those things if we wanted to. Let's see, number 4. What should we do first to solve for y?
Add the cube root over y.
Subtract 1/2 x.
I would subtract the 1/2 x. Can we add the cube root of y and subtract the 7? Yeah, does that work?
I don't think so.
Mama, yeah, I'd want my cube root to be positive. So if I switch some things around here, I added the cube root of y to one side, and I subtracted the 7 to the other side. Do you see how I did that?
Yeah.
Yeah? Okay. Now, how do we get rid of the cube root? Cube. Cube both sides. So the cube root and the cube undo one another. And so we get y by itself. And then we have this great big thing that I'm not going to bother to multiply out. Let's see. Do we think it's going to be a function or not a function?
Oh, yeah, because it's...
So when in doubt, graph it out. 1/2 x minus 7 quantity cubed. So when I plug in an x, I do some stuff and then I cube it. How many answers am I getting? Let's see what we get here. This is probably, oh, there it is, way down there. Let me zoom out a whole lot. There it is. Is it a function or not? Yes, it's a function. There's no plus or minus here, so we could get just the one answer. Okay, I think we're okay. Let's do number 6. Oh my goodness. Bad camera here. All right, again, we're trying to get y by itself, but we got a couple of y's here. What do you want to do first? I'm not going to switch to 5 and 2. I'm going to add the 1 for sure. So xy minus 5y equals 2x plus 1. Now, I see something in common here. GCF. GCF, there's a y there that we can undistribute. If I undistribute the y, what's left behind? X minus 5, good, is equal to 2x minus 1. And then how do you get y by itself? Oh, thank you. X minus 5. Good. Divide by x minus 5. So y is by itself, and I would have 2x plus 1 divided by x minus 5. Beautiful. If I plug in an x value, how many y values am I going to get out? 1. So this is a function. All right. There's no plus or minus to worry about there. All right. Very good. Explicit functions are frequently written using function notation. We use function notation all the time. You're going to get really good at function notation. So instead of writing something like y equals 3x squared minus 5, function notation, we are going to use f of x. F of x is how we say that, equals 3x squared minus 5. The only difference is I like to call it a fancy y. That's f for fancy. Okay, what this is saying is we have some function. The f is for function, but we can change the name. So when we're looking at lots of different graphs, we're going to call one of them an f, one of them is a g graph, one of them is h graph. So we can use different letters to represent the different things we're looking at. This says we have a function, and this means in terms of x. We read this as f of x, and it's interpreted as the value of the function at the x value. So what is the output is really what we're looking for. We use function notation mostly when we are evaluating functions. It's super duper useful. So to evaluate the function, you can see here we have f of negative 5. You'll notice this, if you line things up here, we have the f. And what did they do instead of x? They gave us the x value of negative 5. And so they're telling you, hey, go ahead and replace the x with a negative 5 everywhere you see it. So everywhere you see an x, we're going to go ahead and plug in that negative 5. And that's what the function notation does for us. It tells us what to replace the x with. So it's really quite handy. A negative 5 squared is? Oh, careful. 25. This is negative 5 times negative 5, which would be positive 25. Negative 6 times negative 5? 30, positive 30 plus 23. I'm getting 2078. Can I get a second? So we would say f of negative 5 equals 78. Now this is really important you understand this is notation. Is this saying f times negative 5 is 78 and I need to go divide by negative 5? Do I need to do that? No, this is done. The reason we like function notation is because what I just learned is that this is an ordered pair on my graph. I just found a solution on my curve. The ordered pair was an input of negative 5 and an output of 78. So somewhere on my graph, I have negative 5, positive 78. Okay? It's part of the graph. It's part of the solution to my curve here. And so function notation becomes very, very useful. What is h of 9 telling me to do? Replace the x with the 9. Good. So we have 7 minus 9 being squared. So this is going to be 7 minus 81, which is 74. Negative 74. Beautiful. Thank you very much. All right. I'm going to do a few more of these. Number 9. What's P of 4 telling you to do? Replace the x with a 4. So we would have 4 plus 1 over 2 times 2 times 4 squared plus 4 times 4 minus the 13. I'm going to just do this sort of in steps here. I know the numerator is 5. Let's see. 2 times 16 is 32 plus 16 minus 13. So P of 4 is going to be 5 over 35, which reduces to 1/7. Good. What's the ordered pair that I could graph? 4 and 1/7. Yep. Over 4, up just a tiny, tiny bit. Okay? A little tiny point on my graph. I'm sorry, say again?
Why is it the 4 and the 1/7?
I'm just pointing out that we have this ordered pair right here from the input and the output that we're getting. Again, I just want to reiterate, when we're using function notation, that is also giving us an ordered pair on our function, a little graph, a little point on the graph, okay? So I really want to make the connection to doing algebra and then also what it is visually, right? All right, Q of x. We want to do Q, and what are we plugging in? Negative 15. All right, so I have the square root of 6 minus 2 times negative 15. Let's see, what do we have to do first? Simplify, yeah, so what part? Do we do 6 minus 2? God, I hope not. Or, yeah, so that's going to become 6 plus 30, which is the square root of 36. What is the square root of 36?
Plus or minus.
Not plus or minus. Not plus or minus. I'm really glad you said that because we are not solving, we are simplifying. This is indicating that we only want the positive radical, the positive square root. If they wanted both, they would have put the negative on there for us already. Okay, so just 6. All right, fantastic. Yeah, we're going to skip down here. Let's do 15 and 17 here. They get really good. So function notation is fantastic for plugging in values, but you also have to get really good at your algebra skills. So here on number 15, it's saying we have f of 3y squared. What is that telling us to do? Replace Replace our x's with 3y squared. Yeah, everywhere there's an x, it wants us to replace it with a 3y squared. All right, what is 3y squared to the third power? 27y to the 6 is correct, my friend. 3 times 3 times 3 times 3 is 27. Y squared times y squared times y squared is y to the 6th power. Very good. All right, what is 3y squared?
9
to the second power?
9y.
9y to the 4th. Very good. So can we do any more with that, or is it done?
Can you simplify more? Done.
That's all we can do. They're not like terms. They don't have the same exponents. Okay, so they are not friendly. That is done. That's all we can do. Number 17 is really good. This is like week 1 of calculus, in case you're curious. This is what we do week 1 of calculus, right here. So we have h of 2a plus 7. And so, what is this notation telling me to do? Replace. Replace the x. Be very careful when you replace the x with 2a plus 7. Use those parentheses, okay? Now, ladies and gentlemen, what do we have to do with 2a plus 7? Quantity squared. Double it. Yes, it's 2a plus 7 2 times. And what do we have to do? Multiply them together. What do we get when we multiply them together? 4a squared. What's the outside? 14a. And what's the inside? 14a. So we have 14a and 14a, which makes 28a's. And then last times last? 49. Be very careful. Any questions on where that all came from? Okay, and then we have to distribute our negative. So negative 2a and negative times 7 is negative 7. And then our minus 1. And now we can do a little bit of cleanup. 4a squared, we have a 28a and a negative 2a, which is 26a's. And then 49 minus 7 minus 1. So 49 minus 8, 41. Very good. Excellent day. And that's all we can do there. Questions on that? Pretty good? Okay, now the really, really easy part real fast here. We are going to use the graph to evaluate the function. So find each function value. They put in a 1. What did they put a 1 in place of? The x. So they're telling you that if x equals 1, what's the y? What's the output? That's what we're trying to figure out. So if x is 1, what's the output value? Right down here, which is 1, 2, 3, oh, I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. The ordered pair would be 1, negative 9. All right, if f of negative 2, what's that telling me?
0.
Yeah, the x is negative 2, so where is the coordinating point on the graph? Right there at 0. The y value is 0. Negative 2, 0 is a point on my graph. F of 5. 1, 2, 3, 4. Oh, 5 is right here. 1, 2, 3, 4, 5, 6. Yeah, it's a really small graph there, but 5, 6. Again, the ordered pair would be 5, 6 on my curve. And then F at 0. Negative 8. Very good. Right here, the point on my curve is 0, negative 8. Okay. No. Do you have questions for me? All right, fantastic. Let me release your adult to math.
May I go to Mr. Henry?
Yes.